Assessment, heaps and hashing. For question 1, heap insertion, we are given this min-heap right here, and we add the node 0 to it. I'll add the value 0 or element 0. So here I added to the end of the list of the min-heap, and it's at the bottom right, as you can see here. And then we swim the node. If the parent node is higher in priority than the child node, then we swap it. Here's 4 is bigger than 0, so we swap it. Then here 2 is bigger than 0, so we swim 0 again, and 2 is bigger than 0, so we swap it. Then we swim 0 again, and then 1 is bigger than 0, so we swap it. And this is my final result on how I got A, B, C, and D. For question 2, heap removal, we're given a min-heap, and we call removeMin 3 times. For the first call, here I swap the top node with the top node, or the first thing in the first element in the min-heap with the last element in the min-heap, so I can remove it. And then I sync the top one because to maintain min-heap property, since 6 is, you guys can see, is bigger than its child, and that is not the min-heap property. So I sync 6 with the lesser child, which is 2. 2 is lesser than 3. So I swap it, 2 and 6, and then swap sinks, and then I sync 6 again because it doesn't maintain the property. So I swap 4 since 4 is the lesser child. And then I call removeMin again, swap it with 8, do the same thing, swap it with the last element, remove it, and then I sync 8 because it's bigger than this child. And then I can swap it with the lesser child, so 3 is the lesser child in this case. So swap and then sync, and then I call removeMin again, and then I swap it, remove it, sync it again, and here's how I got my answer. Question 3, hashing. So for this one, here I look at the code and the bucket size I was given. So here I draw out the buckets, and then here, as you can see, the hashing. In order to find the bucket, it's a name.length mod 4. And then here, as you can see, for Husky A, we're given the name.length, and for Husky B as well. So when we put A and B, we mod it by 4, and I get 1 and 1. So this is what it looks like now. And then we do A.name plus equals A.name. So the new name is Jeter, and that's 10. So 10 mod 4 is 2. So now this is passed by reference, by the way. So the value in A here has also changed as well because it's passed by reference. So now there's a new A here, which is 3. And this A right here at the top is inaccessible. We can never access that again because now A's whenever you hash A, it will be in the index 2 bucket. Then we do map.put B4, and what that does is it just replaces the value here into 4. Then we do B.name plus equals B.name. That becomes Diane, and then you put it in the map again, and we bucket that. That's 10 mod 4 equals 2. So here, and same thing that applies to A is that the value here is it's also changed. B is also changed, and now we cannot access B anymore. So that's what I want to note. And now we can answer the questions. For question 1, it asks for map.size. As you can see here, these things still exist in the map, but they're just inaccessible. So there's still 1, 2, 3, and 4. 4 items in the map. Therefore, map.size will return 4. For question 2, why does map.get new Husky Jeter return null? That's because when we do this, it will mod it by 4, and then we'll access index 1. But we remember that A is passed by reference, right? Because it's an object, it's passed by reference, so it has changed to Jeter. So when we check this, it will be Jeter, and therefore there won't be an actual a new Husky Jeter. Therefore, it will return null. So for question 3, map.get new Husky Jeter. Well, you do the hashing again, and that's 10 mod 4, that's 2. We'll access 2, and we'll find that A, which is Jeter, has the value 3. So then it will return the value 3 because it is there and it exists in the map. Thank you.